Welcome to my presentation. In this presentation, we shall explain the properties of logarithms. So there are several properties related to logarithms. We will look at each one of them separately. Property number one. If we have b greater than 0 and b not equal to 1, then we can write log b to the base b is equal to 1, right? So because we know that any number raised to the power of 1 will be equal to the same base value or same base variable, whatever. So if it is a variable, if it is a number, it is going to be the base number. Okay, so log b to the base b is equal to 1. This is one property. The second property is if we have log 1 to the base b, that will be equal to 0, because we know that any number or any term raised to the power of 0 will be equal to 1, right? For example, 2 to the power of 0 is equal to 1. 100 raised to the power of 0 is equal to 1, and therefore log 1 to the base b is equal to 0. So this is the second property. And in this case too, b should be greater than 0 and b should not be equal to 1. That is the condition. So the third property we want to know is, again, if b is greater than 0 and b is not equal to 1, and another condition is if r is greater than 0, then we can write this property as follows: b to the power of log r to the base b is going to be equal to r, which is this term here, which is read as b raised to the power of log r to the base b will be equal to r, like that. Okay, so the way we can read this property out is as follows: r raised to the logarithm with base b of a number equals that number. So this will be the same as that number there. Okay, so let us look at some more properties in here. So in the next one is called the product rule. Let me write this one down here. Product rule. In this product rule, if we have log, let's say, r times s to the base b, so we can write this one out as log r to the base b plus log s to the base b. This is what is called the product rule. Okay, then let's see the next property. This is the quotient rule. Let me write this one down here. Quotient rule of logarithms. In here, if we have log a, or let me use another variable here, I'll use log r to the base s, and then log r over s to the base b, the whole thing to the base b. R over s is a ratio, and in this case the way we can expand it is as follows: we're going to write log r to the base b, that is the numerator part, and now this time minus log s to the base b. It looks very similar to the product rule, but in this case we have a negative sign. In the product rule we have a positive sign. In the quotient rule we have a negative sign. So this is the quotient rule. And then one more rule in here, we will call this one as the power rule. Power rule of logarithms. And what is this telling us? This is telling us that if we have log r to the power of p, this whole thing is to the base b, we can write this one out as p times log r to the base b. The p, which was the power, came in front of the logarithm like this. So this is the term which came in front of the log expression. So therefore it becomes p log r to the base b, and this is what is called the power rule. We will use all of these properties to solve some simple example problems in my next set of presentations. In my next presentation, we shall see examples using properties of logarithms.